Hello everyone, welcome to RN Tutorials. We are going to discuss about the subject of mechanics of fluids and hydraulic machines, which is the subject in the second year, in the second semester of students are who studies in JNTU affiliated college, Hyderabad. So now in this first video, I want to give the introduction to the mechanics of solids. Sorry, not mechanics of solids, mechanics of fluids. Here I want to give the introduction to the mechanics of fluids. So first thing, I want to define the mechanics of fluid. The subject, what is the definition for the subject we can give to the mechanics of fluids? Means here I have given the definition. It is a physical science which deals with the physical behavior of the fluids under static and dynamic conditions. So here physical behavior means here we'll be discussing about the variation of the physical properties of the fluid under various static and dynamic conditions. So whenever it is at stationary and whenever it is in motion, so how the properties will be taking place, on the variation of the properties will be taking place. So in that conditions we'll be discussing in mechanics of fluid. So it is generally defined as a physical science which deals with the behavior of the fluids under static and dynamic conditions. So next, uh, again I want to give one more statement, that is it means we study about the variation of the physical properties of the fluids at rest and in motion conditions. Already I told you. So next, this subject, the mechanics of fluid, is further classified into two groups. One is fluid kinematics and another one is fluid dynamics. So we can say three groups also. So how can we say three? Means one is related to the static and another two are related to the dynamics, that is fluid kinematics and fluid dynamics. Okay. So what do you mean by fluid kinematics? Fluid kinematics deals with the study of motion of the fluid without considering the forces causing that motion. So that means here kinematics also will be studying about the motion of the fluid particles. So that means whenever the fluid is in motion, so what are the properties will be taking place for the fluid and how the variation of the properties of the fluid will be taking place in the fluid kinematics will be studying. And here the kinematics means in any kinematics of subject we won't consider the forces which are causing that motion. So similarly here also without considering the pressure forces. So whenever we consider the fluid, we face the force due to pressure only. So without considering those pressure forces, we'll be studying the motion of the fluid when it is in motion. Okay, now so that means we'll be finding the velocity and acceleration. Okay, and the discharge. Okay, these things we'll be discussing in kinematics. Okay, about these things briefly we discuss in next classes. So that is about the fluid kinematics. And next one is fluid dynamics. So fluid dynamics is also one branch of mechanics of fluids which deals with the study of motion of the fluid under consideration of the forces causing that motion. So that means here in the dynamics we'll be studying the motion by considering the forces. So that means here we'll be finding the what are the forces are taking place whenever the flow of the fluid is taking place through a particular channel or pipe or any other thing. So we'll be studying about the forces also. So what are the forces are going to act when the fluid is under motion? So that thing we'll discuss in the dynamics. Okay, na? We'll be studying about the motion by considering the forces in the fluid dynamics. That is about the fluid dynamics. Okay. So next thing we have to know, what is the definition of the fluid? Okay, now before going for the discussion of the subject of mechanics of fluid, so we have to know what is a fluid. How can we define a fluid? Okay, how it is different from the solid. It means here it is defined as a substance which is capable to flow by the continuous deformation of the fluid particle. So that means here it should be able to flow from one place to another place by the continuous deformation of the fluid particles whenever certain external force will be acting, whenever certain external pressure force will be acting on the fluid. Okay, that is the definition for the fluid. So here, according to the molecular condition, we can differentiate the fluid and solid. So here, when you compare the molecular distance for the solids and as well as fluid, here in fluids we'll be having the molecular distance more than the solids molecular distance. Okay, so by the molecular distance we can define the fluid and solid. Okay, where the molecular distance in solids we consider the molecular distance as 0. For fluids there will be certain molecular distance will be taking place, so free movement of the molecules will be taking place for the fluid. Okay, according to that we can differentiate the fluid. So next I want to go for what are the main two types of the fluids. Okay, now so fluid is a substance which is able to flow, and next in that fluid if any types we are having. Yes, we are having the two types of the fluids, one is liquids and another one is gases. Okay, this one is also defined or differentiated based upon the molecular condition only. Okay now, so what do you mean by liquid? So liquid is also fluid where the free movement of the fluid particles takes place, and which will be having continuous attraction and repulsion of the molecules, fluid molecules, that is the liquid molecules will be taking place. So for liquids we can take the example as a water is a liquid which comes under the category of fluid only. So when you take the liquid in a container, so how much the volume we are taking equal to that volume, it will be occupying the container, and the liquids don't have any particular shape. Similarly the gases also don't have any particular shape. So in whichever the container will be taking the fluids, so the shape of the container will be given to the fluids. Similarly, whenever you take the liquid, that is water in the container, the shape of the container is obtained by the liquid inside the container. Okay, here the gas is, when you take the gas in a container, the gas will be occupying the entire volume of the container, even the mass is less than the mass of the liquid that you have taken. Okay now, in the container. Okay, so even the volume here, the volume assumes certain V1, and this volume is V2. Even the V2 is less than V1, so the gas molecules will try to occupy the entire volume of the container. Why? Because there is a free movement of the molecules will be taking place, and here the attraction forces are very less as compared to the attraction forces between the molecules of the gases. So due to that, the free movement of the molecule causes the occupying of the entire volume of the cylinder or container in which we take, even the mass is less. Okay now, so due to the free movement and less attractive forces in between the molecules, the gases can be defined. So based upon that, here based upon again here based molecular distance condition, we can differentiate the liquids and gases. Okay now, so here that is about the liquids and gases. And next we go for fluid is further classification. The further classification of the fluid is ideal fluid, and second one is the real fluid. Okay now, so fluids we are having liquid and gases, as well as in that there will be ideal liquid, real liquid, ideal gas, real gas will be there. So how can we define the ideal fluid and real fluid? Means ideal fluid is defined as the fluid which is incompressible and non-viscous. So incompressible means which should not undergo any volume change whenever you apply the compressible forces. When you try to apply the compressible forces on the fluid, there should be no change in the volume. So then that fluid is called as incompressible fluid. So non-viscous means viscosity is the one of the properties of the fluid. So about the viscosity we'll be discussing. So whenever you consider the ideal fluid, the viscosity of that fluid should be equal to 0. So when there is no viscosity and when the fluid is incompressible, there is no change in the volume of the fluid whenever you apply the compressible force. So that kind of the fluid is called as ideal fluid. And similarly, what do you mean by real fluid? Real fluid is existing fluid, so which is defined as a fluid which is viscous. Okay, now viscous means it should have certain viscosity value. Okay, so and it should be compressible. It may be compressible or it may not be compressible, but if it is having certain viscosity value, so that fluid is considered as real fluid. Ideal fluid in the universe, it won't exist. By certain assumptions, the water will be assuming as the ideal fluid, and real fluid means whatever the existing fluids we are having in the universe, those are all called as real fluids only. Okay na? So that is about the types of the fluids, that is ideal and real fluids. Okay, so this is about the introduction to the mechanics of fluids, in which we have to know what is the definition of the fluid mechanics, and what is the definition of the fluid, and what are the different types of fluids we are having. Okay, so I hope you understand a little bit introduction to the mechanics of fluids. So next in further video we discuss about basic properties of the fluid. Okay, in mechanics of solids we'll be studying about the behavioral changes of the fluids under various conditions. So based upon that, we have to know what are the properties will be taking place for the fluid. Whenever you consider the fluid, what are the properties it can have, so those properties we have to discuss. So next further video we'll be discussing about that. So I hope you understand the small introduction to the mechanics of fluids. So once again, thanks for watching my video and don't forget to subscribe to my channel. Thank you all.